This is a problem that mathematicians have always faced with, right? Because anything can be studied using mathematics, or at least claims to be. Some people say, oh no, poetry cannot be studied using mathematics. Poetry is intimate, it's about my feelings, how can that be mathematized? I have news for you, it can be mathematized, right? So, therefore, assuming that you are a mathematical colonialist or imperialist, and you can colonize all of the universe using mathematics, it becomes very hard to find out what is it that could be outside mathematics and why. If everything can be studied using mathematics, aren't we better off just doing it? So same thing with computers. What lies beyond the pale of computers is a major, major problem. And one answer to that, and which is where this field actually comes back sort of roaring sort of in the anti-computational stance, is consciousness. Right? People say, yes, anything that consists of processing, I can understand. Somewhere maybe it's a computer. But I'm not interested in processing. I'm interested in what it feels like. I'm not interested in how short wavelengths are converted into blue and long wavelengths are converted into red. I'm interested in why red feels red. Because you can't tell me that the answer to that question is because red is this frequency turned into that feeling. Because it doesn't tell me where I got the feeling from. Because you could turn that frequency into zeros and ones. You could turn that frequency into, maybe you see dancing, whatever, girls. It could have transformed itself into anything else, but it transformed itself into that red. And that's the problem. Why is it that A, it feels red and not blue, and B, where is the redness of that red coming from, which differentiates that red from blue? And once you ask this question, it's clear that however many numbers you crunch, you're not going to tell me where the blue of the blue is coming from and the red of the red is coming from. You can tell me how red and blue mix together to form some other color. You can tell me all these things. All these transformational questions you can answer. But you can't tell me what is the thing itself. And this is back to the Cartesian thing. I think, therefore I am. You can have all these rules of thinking and whatnot, but that transition from I think to therefore I am seems to be not a computational transition. And therefore, whatever it is, seems to be outside the pale of computers. And once you accept that, somehow, incidentally, the one Bible of cognitive science is Steve Pinker's How the Mind Works. And Steve Pinker's How the Mind Works says there are two rules to how the mind works. Rule number one, we are computers. Rule number two, we have evolved. And he makes this nice, beautiful story of how we evolved as computers. But he says there's one thing which is outside, which is consciousness. So he also agrees that for whatever reason, I can't explain consciousness. And if you are clever, so remember, going back to a 20-year strategy, if you want a 20-year strategy of something new, you start from an obvious place where the previous one goes wrong. So consciousness is a place where it's clear that the computational theory of mind fails. And even any materialist theory of mind so far that we have also fails. And once you drill that point 100 times and everybody's clear that there are certain aspects of the mind that are not computational, then you can say, I'm going to come up with an account of the mind which is from the beginning not a computational account of the mind. And I'll use that to explain memory and language and grammar as much as I will use it to explain consciousness. And my theory, because it also explains consciousness, is more powerful than any computational theory. That's the long-term bet. And that's what the embodied cognitive science people are beginning to make. Right? They are saying, we have an account which doesn't artificially distinguish between first-person subjectivity and third-person abstract processes. and we will therefore use this account to explain everything. Of course, the computationists say you neither explain consciousness nor do you explain language, but that's where the fun is. Okay, is how does this new approach begin to reconceptualize the problem of the mind? Not so. How do you do it? You do it by going back to the foundations. You say that look, computation depends as much on an input-output model of the mind as the behaviors. So I'm going to start by rejecting the input-output model of the mind. Once I reject the input-output model of the mind, I don't have to invent computational explanations. And since I don't have to invent computational explanations, I can do whatever I do. Okay? So we'll therefore ask, how do you go beyond the input-output model of the mind? But that comes later in the week. Okay? But that's broadly the story of computation, which is accept that the mind is an input-output device, ask what kind of inputs does it have, what kind of outputs does it make, and what is my account of the gap between input and output. So if it is language, it is one kind of input. If it is vision, it's another kind of input. If it's memory, it's a third kind of input. And similarly the outputs, and similarly the computations. But what's beautiful is you can test these out explicitly, you can experiment with people, you can also build machines, and so you have a very rich range of possibilities. Okay. And that ability, it's in that sense, it's a very productive, generalizable research agenda. And now, partly as it is suffering in cognitive science itself, it's taking over biology. Right? So the more, if you look at molecular biology sort of ran through its recipes, and I think it's pretty much reached the end of the line as far as radically new things to do. And what's clear is that computational ideas are where much of the new action is in biology. So systems biology, for example, is riddled with ideas of computation, networks and circuits and all those things. So it's not just our neurons that are computational devices. It may turn out that our entire biochemical complex is a computational device. And that's really interesting because it tells you that perhaps the specific idea of computation, which is driven by neurons firing, spiking patterns and all of those, is a limiting idea of computation itself. The computation is more general than neural computation. The bacteria might be doing computations too. And if that's the case, computation becomes a much greater unifying principle in biology than just being something which is good for studying people and monkeys. So it's not at the extreme end of the biological spectrum, but at the very ground of biology. I think that's very exciting. So let me stop there for this session. Questions?
I want to know about the foundational assumptions of this cognition, because if you take example of physics and mathematics, there are foundational assumptions like in mathematics, like numbers are there, geometry, lines, code, set theory, measure theory. These are foundational courses. That's why in mathematics and physics, laws of physics, there are assumptions. And based on the assumptions, the laws of mathematics or actions of mathematics, it develops. But here, what are the foundational? If you want to build some subjects, if you want to develop a subject, it needs to be building blocks. What are the building blocks of this whole area of cognitive science? We should assume, or we should make assumptions or actions like that we are building.
So the quick answer is what? So the standard answer, right, is Steve Pinker's answer: evolution, competition. Okay? These are the two building blocks, but they are false building blocks in several ways. One is that actually maybe they are not actually the building blocks of cognition. But the second is they are hardly foundations in the way that physics and maths are foundations. But you also have to recognize that both physics and maths took 200 to 300 years before they developed foundations. I mean, foundational questions were not asked in maths till the late 19th century, until set theory, or maybe before that.